Okay, so now we'll do forward and backward difference. So the forward difference of any term is given in the form of delta, right? Delta and that term. So let's assume you have like terms y0, y1, y2, y3, y4, and so on until yn. Now the forward difference of, let's assume y0. The forward difference of y0 is given by y1 minus y0. The same way forward difference of y1 is given by y2 minus y1 and so on. This is what is called as forward difference, or here let us call it as first forward difference, because we'll be using these terms in the questions. Call it FD. Now in the same way for second forward difference, it is represented with the form del square of y0. This is basically you are subtracting the forward differences, not the terms directly, the forward difference. So del square of y0 is given by del y1 minus del y0. So what will be del square of y1? That will be del y2 minus del y1. So I understand. I think you guys get the logic here. So this is forward difference. Now let's go to backward difference. Backward difference is basically del y naught. It's basically just the reverse form. Its backward difference is y naught minus y1. Del of y1 is y1 minus y2. Now in the same way, this is first obviously. So the second, what is the second one? Second backward difference be? It would be del square of y naught be del y naught minus del y1. Del square of y1, what would that be? Del y2 minus, oh sorry, del y1 minus del y2. So this is the basics which you need to know for Newton's forward and backward difference formula. Okay, so Newton's forward difference formula, which is basically yr is given by y naught plus r into delta y naught plus r into r minus 1 upon 2 factorial into delta square y naught plus r into r minus 1 into r minus 2 upon 3 factorial into delta cube y naught and so on. I think you guys get the logic now. As we talk about r, now x we can write it as x naught plus r into h. So r is given by x minus x naught upon h. Now if you're wondering what h is basically the width. So let's assume I have my x values in the table as 2, 4, 6, 8, 10. Now what is my h value here? It's basically the difference of these two intervals. Since it's equal on all intervals, my h value will become 2. So my h value is 2. Now if you're talking about x will be given in the question. If not, you just leave it as it is as x. And as about x naught is the first term. Here x naught is 2. So that is how you find r in Newton's forward difference formula. As we go for backward difference, the formula is yr equals, instead of y naught we write yn plus r into delta yn plus r into, instead of r minus 1 in this formula it becomes r plus 1, 2 factorial delta square yn plus r into r plus 1 into r plus, oh just a minute, r plus 2 into delta cube yn whole divided by 3 factorial and so on. It's the same logic, but instead of r minus 1 it's r plus, and instead of y naught you put yn. Now here also you have a different way for R. R is given by x minus xn instead of x naught upon h, where xn will be your last term of x. Now if I assume here x has 5 terms, xn is 10. And then now we'll continue with the sum. Now they have given us that use the appropriate formula and find the value of f of 42 and f of 85. So here they are asking us f of 42. So that means my x value is 42 and f of 85. That means my x value is 85. Now x is 42. That I'll do the first part first. I'll divide as a two parts. Now I should find what is the value of the function when x is 42. Now since I got my x value, I'll make the same table. I'll just write it down. Instead of f of x, I'm writing y to make it easier. Now 40, 50, 60, 70, 80, 90, 100. So what will my h be? H is 10. My x is 42. What is my x naught? My x naught is 40. First I'll use forward difference formula here. Now I'll find out r. What is r given by? R is given by x minus x naught upon h. That means 42 minus 40 upon 10, which is 2 upon 10, which is 0.2. I want my r value. Now the other values which I need are del y, del square y, del cube y, and I substituted in my forward difference formula to get my final answer. Now for del y, I'll use these two. 204 minus 184 is 20. 226 minus 204, that is 22. 250 minus 226 is 24. 276 minus 250 is 26. 304 minus 276 is 28. Now what would this be? This will be 2. 24 minus 22, 2. 26 minus 24, 2. 28 minus 26, 2. Now if I do this, be 0. 2 minus 2, 0. 2 minus 2, 0. Now to make it easier on what values to substitute in forward difference and what values to substitute in backward difference. For forward difference, you draw a line like this, and these are the values to substitute in your forward difference formula. And if you draw a line from the bottom edge of the table, these are the values which will substitute for backward difference formula. Now since I told you for first step I'm using forward difference, I'll use these values. Now by using Newton's forward difference formula, yr is given by, what was my formula? Y naught plus r into del y naught. So what is y naught? Y naught is 184 plus r is 0.2 del y naught, which is 20, plus r is 0.2 into 0.2 minus 1, r minus 1. Delta square y naught is 2 into 2 upon 2 factorial plus 0.2 into 0.2 minus 1 into 0.2 minus 2 upon 3 factorial into what is my del cube? It is 0. So obviously this whole term becomes 0. We are left with first terms, which is 184 plus 0.2 into 20 is nothing but 2 by 10. 2 by 10 is it will be around 2 by 10 is what? 0.2 into 20 is 4 plus 0.2 into 0.2 minus 1, which is 0.2 into 0.8 minus 0.8, sorry, minus 0.8, and 2 factorial gets cancelled with 2. So now I have is 188 minus 0.8 into 0.2. So when I do this, I'll get my final answer as around 187.854. 187.854, which is almost equal to 188. So the value of f of 42 is 188. Now, for f of 85, I'll use backward difference formula here. I think you can do it as like both formulas will work either way. So if I substitute here for the new r as 85 and then 40, I'll still get the same answer as what I'll get when I do backward. Easier way to understand this, when you have when your x is in the top half, here it's 42, 42 will be somewhere here. Then you use forward difference because it's in the top half of the table, so it'll be easier. And since 85 is in the bottom half of the table, I'll use backward difference here. So I have three now for the formula. Here x is 85, x naught, xn is how much? Xn is 90, and then I have my h value which is 10. Now what does my r value become? R value for backward difference is x minus xn by h. So 85 minus 90, which is minus 5 upon 10, will give me minus 0.2. Oh, sorry, minus 0.5. My bad. So minus 1 by 2, so it will be minus 0.5. Now I'll substitute everything in the formula. YR equals YN. What is my YN here? 90. 90 plus R is minus 0.5 into del yn. Del yn is basically this 28. Oh, sorry, this is not 90. My bad, my bad. This is how much? 304. Yeah, that's what I thought was wrong. Next now minus 0.5 into 28 plus minus 0.5 into minus 0.5 minus 1. Oh, sorry, plus 1 divided by 2 factorial into del square is 2. And then my third term will obviously be 0 because my del cube y is 0. Now when I solve all of this, I'll get my answer as around 289.75, which is almost equal to 290. So the value of f of 85 is equal to 290. So this is how you apply forward difference and backward difference formula when you have a respective question and you have to find out any certain value with the given x. So your first step will always be to find out your h, find out your x first, then find out your h, then find out your r with the formula, then substitute all in your Newton's formula, Newton's forward differentiation and Newton's backward differentiation.